Okay, we're going to get started on part one of our final semester project. This will be the initial form finding phase, so you all have a Rhino model, and it has the base mesh that we'll start with. This is a mesh that's around 14 foot square, and it's broken down into 15 faces in one direction and 15 faces in the other. And then what happened was there was just a deletion of the mesh faces in the corners, so just four of the meshes per each of the four corners were deleted to give us a little bit of a curve at our footing. The next thing that we'll do then is just kind of add a few things to this. So I'm going to go to my top view. And I'm just going to draw a NURBS curve. And making sure you have your little vertex O-snap on at the bottom here so you can snap to these corners, right? Because this is a mesh, not a surface. And I'm just going to draw a curve in each one of the corners, starting with the corner point, this kind of midpoint here, and then down like that. So it's basically going to draw a nice little arc in between those 3 points, a little NURBS arc. Okay, like this. And then we need to set some groupings of points that we'll use to control the simulation. So we need some anchors first. So I'm going to go to the point tool and just click at the outer corners first on all sides. All right. Then I'm going to need to establish a couple of points that are from the mesh that I'm going to pull to meet this little arc that we drew there. So I'm going to grab more points and just identify those 3 that are kind of bound within the corner there. Like that. And then lastly, what we'll do is we're just going to, I mean, you can do this in Grasshopper as well, but I just thought since it's not going to take too long, we can just kind of identify all the side points here, because these kind of outer mesh points just snap to each vertex. This is very, very important that the point rests at the exact vertex of the mesh. If it's a little bit off, you'll have a problem. Okay, so that's going to be one thing to look for if your simulations in the next step don't look like mine. It's maybe because these vertices misalign with the point you just drew, which we don't want. So it has to be snapped to it. So again, make sure your vertex snap is on as you're doing this. Okay, so that's good enough for our base. The next thing we'll do is we'll start putting stuff here into Grasshopper. Okay, so I'm just going to set my mesh in, hide that, and then I'm going to set in my curves, right, my kind of base curves. So I'm just going to set these in, and let's pay attention to the order that you bring them in. Okay, so I'm going to work counterclockwise from the bottom left corner. This is extremely important for the next step. We're going to try to make our code as efficient as we can, just by remembering what order that we place the objects in. So I'm going to start with bottom left and go around counterclockwise. You can choose whatever order you like, as long as you remember what it was. Okay, so those are now in a list in that order in Grasshopper. Okay, so that's important to remember, because we're going to associate these 3 sets of points with each one of those independent curves, and we don't want to cross-relate them. Before we get to that, let's set in the anchor points. So I'm going to set multiple points, and it doesn't matter exactly, it doesn't quite matter what order these are in because they're static points, but I'm just going to work around the circle here. And then I'm going to just right click on that and label this thing anchors, and then hit the little button here so that I could label it. These are pretty self-explanatory, so I'm not going to worry. Next thing I'm going to bring in is those points, the points that I'm going to pull to the curve. Okay, and here we have to match the same order that we input the curves. So let's go to multiple points here, and I'm going to go ahead and select these in the same order. So the first 3 in the bottom left, and then the next 3 at the bottom right, and then the next 3 at the top right, and the next 3 in the top left. All right, hit enter, and you now have a start at associating these points with those curves. There's one more step to do though. I'm going to call these pull points. All right, so I don't get myself confused between the two types of points that I have here. And then lastly, just going to bring in those edge points as well. And here again, the order doesn't matter quite as much. But just to be safe, because it may be a little bit easier down the line, I am going to select these in order. I'm going to start with this leftmost edge and then and then kind of carry myself around counterclockwise. All right. You could probably select these with the window, but again, a little bit later on, we're going to need these points to be isolated from the rest, and I'm going to make my job a little bit easier. All right, I'm going to call these edge points. Okay, that didn't take very long. Okay, so we're good. We're set to start adding grasshopper goals, or kangaroo goals, I should say. And before I get any further, though, I do want to mention that this Rhino file, as you might notice, is in inches. We are modeling this to scale. So if you're starting, with a file that's of your own, instead of the base file, make sure that you're reproducing the geometry we have here and also making sure you're in inches, because the entire rest of the tutorial will be based on that. Okay, so let's keep going here. Let's start bringing stuff in, and then I'm just going to hide what we have on screen there and hang on to it just in case we need to make any edits before I internalize. Okay, let's go over to Kangaroo 2. Find it. There it is. First, we're going to go to Goals Mesh. We're going to grab this edge length component here, and we're going to set springs to our mesh. The length factor will be 0. We want to keep that at 0, and our strength in this case, let's just make it 1. Grab another slider. You can always adjust this a little bit later. It may not matter that much. It's not a super intense form finding situation here. We will have some adjustability. Okay, what do we have next? Pull curves and pull points. Okay, let's work with this. Now, let's first take the curves and graph them. So I'm going to right click and graph those so that they can all be on their own list, one curve per list. And now I've got a set of points, 12 of them, that I want to associate 3 per to each one of those curves. So let's go over to Set, List, and Partition. So we're going to partition this list, and we're going to partition it with a number 3 as an input. All right, so I'm going to go to Panel, because basically I want to kind of take the 3 points in order and put them in their own little list. So let's hover over this. Now we have 4 lists of 3 points each, and because we put those points in order, the same order of the curves, that 0, 0 list there with 3 points will correspond to the 0, 0 list here with 1 curve, and it's the right curve. This is going to repeat until the list is completely satisfied, right? So this number 3 here can actually be input as a pattern if you like. So it could be 3, 4, 2, whatever. In this case, we just wanted to repeat 3s until it finishes pocketing all the data points into sets of 3. And in this case, because it's divisible by 3, we have 4 lists. And we also have 4 curves. Okay, so these things we can now associate with one another. All right, so let's go over to Kangaroo 2 again, and we're going to grab this on curve component here, and the points that we're bringing in are those there, and the curves that we're associating with here. Okay. The strength of this we want to keep pretty strong, so this may be a little bit overkill, but I'm going to just turn it to 500, and we can observe what that does in just a minute. All right. With our edge points now, to get the form started, what I'd like to do is constrain their movement only in the z direction. I'd like this dome-like form to have edges that are orthogonal. So we'll head over here into goals point, and the anchor XYZ component is so there's a couple different anchors here. You're going to look for the second one down, XYZ. because this one's going to give us some ability to constrict movement in any of those three directions. I'm going to grab a Boolean toggle and turn it to true, and then I'm going to plug that into X and Y. True in this case meaning yes, it will be constrained. Z meaning no, it will not be constrained. It will move in the Z direction only. It's a little bit counterintuitive. So these points will only, these edge points here will now only move in the Z direction, which is what we're looking for. And then lastly, let's just head over back into that same area, grab an anchor component, the first one in the list there, and we'll just drop our corner anchors in as such. So we have basically our controls, our counter forces, if you will. Now we need to add a live force. We need to push on this mesh in order to get it to simulate into a potentially a compressive form. What I want to do then is add a basically a unary force or an upward force to the points that are inbound on the mesh. Okay, so let's go over to the mesh box over here in Kangaroo, grab the naked vertices component. We're going to use our mesh to find this data. I guess we'll put it here. You can turn that one off so we don't get any overlapping previews. The clothed points, the ones that are clothed, meaning that they're going to be bound within the mesh and not facing any kind of edge, will be there. And then we need to go over to Kangaroo again and go to goals point, and we'll look for the load component here. The points are going to be the clothed points, you can see there. And then we just need to give it a bit of a force. By default, this is going to be the positive Z. We're going to change that to the negative Z. Oh, sorry, no, we won't. We will leave it in the positive Z, excuse me. But just to illustrate that visually, I'll put a Z vector there. And then we just need a slider to go ahead and control this. So let's make a slider, let's say between 0 and 10. Will be more than enough. We won't need that much. And then I'm going to just put a little highlight around it. And to remember that this is basically my force that will be applied. So I can go ahead and control that later. And then the very last thing, we just need to kind of pass the mesh back through so that we get one out as an output. Right, and then I'm just going to go ahead and, for a moment, turn all this off. And then I'm going to grab an entwine component and put it all together within Kangaroo Solver. All right, so I'm going to go to Sets, Tree, Entwine. I'm going to start bringing stuff in whatever order seems to make the most sense. So I'm going to start, I guess, with this mesh so we know where to find it later. I'm going to add a bunch of inputs here. And you can go down the line, adding all your inputs nice and neatly into this entwine component. So all the goals are now set into one little area, and if I need to make any changes, this is a good place to do it. I can then kind of mix and match goals as I feel the need to. All right, I'm going to head back and I'm going to grab my solver here. Okay, this is pretty standard. I'm going to need a Boolean toggle to control whether or not this is on, and I'll also need a button here to reset it. And then my goals object can go right in. All right. So what we're now seeing is the preview basically of everything. You're getting all the vertices and the outputs. Go ahead and turn that off. We're going to go over to Sets. We're just going to, before we run it, we're going to set ourselves up nicely here. And we're going to go to Clean Tree. Right. So we're going to clean up the output. We're going to turn this little E input to true, which is kind of common practice. And now the only thing that we get coming out that has geometric data on it is just two paths. Okay, so we can turn that off. And now we have a mesh and we have a bunch of lines, and that's going to be but we don't necessarily need those. That'll be the mesh edges. Okay, we can now run this, and to do that, I will have my slider on screen. It's going to hit true. You can see right away what happened is those points got pulled directly to the curve already. And then if I add force to this, I will be creating the surface, the shell structure, at least the base for the shell. Okay. Based on my tests, you can play around with this, and you can feel free to make a different. This 3.75-ish is pretty good. It'll end up creating something that's kind of tall in the end, so I'm going to just drop it down to 3.5, just based on the kind of numeric relationships that we're setting up here. Your results may vary a little bit, and you can feel free to try to get it to kind of work within the proportions that you're seeing here. And this is a good start. It's a little low for what we want, but it is a start. The next step of planarizing it will actually add some height to it, so we want to keep it a little bit low to begin with. And it's basically kind of a back and forth trial and error process, some of which that I've already done here. So we'll just kind of work with the values that I've already kind of determined to be reasonable for the scale of this project. Okay, that's it for this part one. In the next step, we will make sure that all of these mesh faces are planar so that we could apply that to our planar material that we'll end up building it from. So we're already thinking in early steps what kind of material we're going to build this out of. Since we're not casting it, we're going to need to think about sheet materials and their limitations. And one of the limitations is that we're going to impose upon this project is that we're going to resist any bending or folding or twisting of the panels, and we're going to optimize them so that they can remain flat but still connect seamlessly. Okay, we'll carry on with part two.